A logarithmic word problem is basically an exponential growth and decay problem, but they give us the answer, and what we're looking for is an exponent. We know any time we're asked to solve for an exponent, we have to use logarithms. But first, let's just approach it like it's an exponential growth decay problem. Johnny invests 3,000 into an account, interest rate of 4.5%. How long until the account is worth over 8,000? So the principal is what Johnny invests. That's the 3,000. The rate is our percentage divided by 100. We want to know how long until, so we're missing the time, we're missing t until it's over 8,000. And so our formula, A equals principal times 1 plus, because we're exponential growth, we're growing interest in an account, plus r raised to the t. What we have is 8,000 is our answer. Our principal was 3,000. 1 plus 4.5% as a rate is 0.045, and you get that by dividing it by 100, raised to the t. That's what we don't know. So we can clean this up a little bit with 8,000 equals 3,000, 1.045 to the t. And before we worry about that exponent, we could actually divide both sides by the 3,000 to make this even a little bit easier. So on my calculator, I'm going to type 8,000 divided by 3,000, and I get a 2.6 repeating. So I'll just say 2.6666 equals 1.045 to the t. And so now this is where we have a number, a base, and exponent. We can use logarithms. So if I take the log of both sides, log of 2.6666 equals log 1.045 to the t. And I know that I got to bring my t to the front and divide both sides by log 1.045. Divide both sides by log 1.045. And I can type this into my calculator now. That log 2.6666 divided by log 1.045, and we get an answer of 22.28. And we're talking about how long in years. So I'm going to round to the nearest whole number, but I want till it's over 8,000. If I round down, it's going to give me just under 8,000. So no matter what the decimal is, because I want over 8,000, I need to round up. So in this case, the answer is 23 years.